This next section, 29.4b, we're going to talk about Trans-Kuiper and Kuiper Belt objects, in particular asteroids. The largest of our smaller body objects in the solar system are asteroids. They're also referred to as minor planets or dwarf planets. Like planets, they orbit the sun in elliptical planes, and Kepler's laws also apply to them. They have perihelions and aphelions for their average radial distance from the sun, and defines their orbits in terms of location and velocity. There are over 794,000 known and cataloged asteroids, and most of these are what are called the main belt. It's located between Jupiter and Mars. So Mars, the next planet out from us, the red planet, and Jupiter, the fifth planet, pretty much in a ball right around here, and actually more of an orbital plane. This main belt begins at about 100 million kilometers from Mars and stretches another 100, so about 100 million out. It stretches another 150 million towards Jupiter. They're usually classified in one of three types, depending on how they're made up and their characteristics. First type, they're mostly carbon compounds, so they have very low albedo or reflectance, almost a perfect black, a 0.03. In fact, the Bennu is one of the ones that my daughter will be studying here shortly. These are aptly called C-type for carbon, and they're mostly found in the outer rim of the asteroid belt. They're nearest Jupiter. So we saw that band on the other slide, the ones on the outer side. They make up about 3/4 of all known asteroids to date. The OSIRIS-REx that was orbiting Bennu, at this time we'll have samples returned to Earth. They're on their way now. They should be here in 2023. This little guy rotates every 4 hours and zips along about 63,000 miles an hour. And it spits little curveballs of rocks into space as well. We got really good images of that recently where the particles are flying out. Another type, the second type, are the iron or Fe and nickel, FeNi metals. They're aptly called the M-type or metal type. They have a moderately bright albedo, 1/10 to 2/10, and they're found mostly in the middle of that belt. So as the carbonaceous are sitting on the outside, these guys are sitting in the middle section. And again, of those asteroids, there are about 90 of these that have been cataloged. So we have all kinds of carbaceous C-types, only about 90 of these little guys. And their composition materials of iron and nickel are the densest, and they're the fastest in terms of rotational speed. So these guys really pivot around. So the class MEM here is asteroid 766 Morgantua. And then we have the M class also of 16 Psyche. See, they used to call this the Death Star also because of that image there. You can actually see the irons in here and the slight green of the nickel compounds. And last is the S-type asteroid. And these are the ones that have the commercial application that they want to go to. And they can be found, in this case, they want to go and actually send probes, put them inside of a bag, clamp them, and then bring them back to the moon to start mining these things. So they literally can be clamped onto and towed into lunar orbit for camp miners. And we bag them and drag them back in the lunar orbit for mining. They can also be pushed or steered. So once you're done with the remnants of this, you've mined all the ore you want, you can push this towards the sun. So we call them the S-type because they're mostly what they call siliceous materials. That means the stuff that's pretty valuable. And they have a very, for most speaking, a bright albedo of the 1/10 to 2/10 as well, if not more. And they're found closest to Mars. That's why you're going to be at Mars in 2035. They're setting up the base camps to go and drag these things back to the moon for mining. There are currently 9,000 of these that have cataloged, and about every year we add another 1,000. So it's where the money is. Because of their composition, like I said, they're money asteroids. They're filled with gold, platinum, rare earth metals, a 1 kilometer diameter, one of these puppies is worth about 300 billion. Here's images of the Ceres, which we also had a flyby, Eris and Pallas. Not in the asteroid belt between Mars and Jupiter, we have others called Trojan asteroids and Earth grazers. And these guys are in clouds. They're in the green dots. So you see they're actually in the Lagrangian points of Jupiter. That's the points where the Earth or the gravity is balanced out. So you get these guys, these Trojan orbits. They orbit just before Jupiter and after Jupiter, as opposed to the ones we just talked about before on the red. Earth grazer asteroids, or NEOs, Earth objects, are not in the main asteroid belt. They're highly elliptical orbiting asteroids. These guys have the potential of hitting us at some moment in time, and there's a lot of them. Here we have an image of one 2004 BL86 passing through the Earth's orbit. It's quite elliptical. So you get an image here of everything of the ones between Mars and Jupiter, the Trojans, and then the NEOs. So there's a lot of debris out there still. And that's the end of this section.